Since I began teaching this class, I've learned a lot about climate change numbers, and I'm going to share some of that information with you on this page before we get into calculating our carbon footprint from driving. So the information on questions 1 through 4 provides some context for us later. Worldwide CO2 emissions in 2020 are estimated at about 34.81 billion metric tons. So remember that the grams coming out of your car's tailpipe don't seem like very much, but this is the worldwide carbon dioxide emissions for 1 year. Billion tons could be gigatons, that's another way of saying that. And the world population in 2020 was 7.64 billion people. So we can write a fraction to calculate the CO2 emissions per person. CO2 emissions on top, number of people on bottom. The nice thing is the billions can cancel out since they're the same, and so when we divide these two numbers, we get about 4.6 metric tons per person. So that's a worldwide average. To limit warming to 1.5 degrees Celsius, humans would need to rapidly reduce our emissions to 2 metric tons per person worldwide. So 4.6 is where we are at. We really should be doing about 2 tons per person. So the current average is over 2 times as much. And I'm sorry, I skipped over this paragraph. This is another piece of important information. Depending on how much we emit, our planet's average temperature could rise between 1.5 and 5 degrees Celsius. We have already warmed 1.2 degrees Celsius since the Industrial Revolution. And this doesn't seem like very much of a big deal, right? If the temperature outdoors warms 1 degree, we would barely notice. But when the whole planet gets 1 or 2 or 3 degrees warmer, it has really dramatic effects on the intensity of hurricanes, for example, or droughts in other areas and heat waves that can harm people's health. So all of these are happening as a result of the warming we've already experienced. And future emissions will determine whether we warm even further. So this recommendation came out of computer models that we should limit ourselves to 1.5 degrees Celsius. .6 divided by 2. So if we divide to compare, we get 2.3. So it's over twice as much as the recommended per capita emissions. Now if we go and calculate the same fraction for the United States, we have 5.16 billion tons over 330 million people. This time billions and millions can't cancel out, so look how I handled this. 5.16 E9, 330 E6. That's a nice shortcut for billion and million. That's scientific notation in calculator speak. Or I wrote out the number in standard notation to divide and got 15.6 metric tons per American. So you can see that we have a much higher carbon footprint than the worldwide average. The U.S. average is almost 8 times the per capita emissions. 15.6 divided by 2, the recommended per capita emissions, and it almost is 8 times as big as it ought to be. As citizens of a society that relies heavily on fossil fuels, we may feel like there isn't much we can do. But the world has actually made a lot of progress on reducing emissions. So it's helpful to be aware of the situation, about the impacts of our choices, and we can also support innovations, and we can vote for leaders that will invest in reducing emissions. So when we drive, we burn gas. Emissions come out of the car's exhaust. Another way that we emit carbon is flying. Flying has a really big carbon footprint. So in the next few pages, we're going to look at the carbon footprint from driving and from flying. The information in this paragraph we will use on the next page to calculate Ben and Tammy's carbon footprints from driving. Begin each calculation with the miles per year, because that's the personal part of the story. The rest of the rates are given by their vehicles or by other facts.